Hey there, welcome to this practice set on relations to functions. Please like and subscribe for more math help, drop a comment or question below, and check out the other videos and playlists on the channel. Now, full disclaimer, I mentioned in the intro video to the channel, if you haven't watched that I am not a whiz-bang kind of person. I actually prefer teaching with like a piece of paper and a pencil. So I apologize for the awkwardness of some of the graphics on this. It is what it is. I'm not whiz bang. We're going to learn the math, but it ain't going to be fancy. So anyway, pause the video to work these problems on your own and then come back to check your work. Okay, so for this first one, I'm going to try to keep the coloring as consistent as I can. The first part of this was to take the mapping and write it as like in that vertical with the circles. So I'll set up a circle for my x's and a circle for my y's. In my x set, I've got -2, 0, 2, and 4. And in my y set, I have -2 and 0. And then I'm so sorry, this gets like a little bit hard to trace. The -2 is mapping over to the -2. 0 is mapping to the 0. The 2 right here is this one cutting across here to the -2. And then 4 is the one kind of ducking down and mapping to the 0. And now, if you got that wrong because of the terrible graphics that I have on there, okay, but you were looking for the right thing, like you were genuinely trying to trace the arrows, then give yourself credit, okay? It's one thing to like get something wrong because you don't know what you're supposed to be looking for, and it's another thing to get it wrong because you like couldn't see a graphic well enough. Okay, those are two totally different reasons to get something wrong. So that's what the mapping was intended to be. If there was an issue with it, I am so sorry. You can leave me a mean comment. You know what? Don't leave me a mean comment, but you can comment on it. Okay, just it doesn't need to be mean. Now, second question there, kind of going to the third question. So we'll do like 1 and then 3. Graph the mapping for number 1. Is it a function? So you might be able to tell from this notation that yes, it is a function because it does go, each x value is only going to one y value. But what we want to do to construct the graph is we do want to look at what that mapping is. So -2 maps to -2, which is right there. 0 maps to 0. 2 also maps to -2. And 4 maps to 0. So we end up with that collection. And what we're looking for in that graph there is whether we have any points that are stacked on top of each other. And you can see that we don't, okay? Do we have some duplicate y values? Yes, but they're not stacked on top of each other. So it's fine. That is a function. Each x goes to only one y. Now, for this one, let's go ahead and see if we can do a little bit better on this one. Our x's is 1, 2, and 3. Our y's are 10, 11, 12, and 13. 1, oh gosh, okay, this might be easier to see. I should have done these in different colors. The 1 we have mapping to the 10. The 2 is mapping to the 12. And the 3 is mapping to the 13. And then the 3 also has a mapping to the 11. Okay. And again, if you mess that up because of the lines getting tangled, but you were looking for the right thing and you just kind of went on the wrong arrow, you give yourself credit for it. Okay, like you don't mark it down, you don't get mad at yourself, like you say, man, that internet lady and her arrows, she's got issues, which you would not be wrong. Okay, now graphing the mapping, and is it a function? Now we know it's not a function right here because it violates the definition. We can't have one x value going to two different y values. But let's look at what those points are. We would have 1, 10, 2, 12, which is going to go off my grid there, 3, 13, and 3, 11. So 110 puts me up there. 212 would put me like here. 313 puts me like there, and then 311 puts me right there. And as we noted, this is the thing that disqualifies it. Okay, you cannot have the dots, your points stacked on top of each other. If they are stacked on top of each other, it is not a function. Okay, so for this one here, yes, this is a function. This one is no, it is not a function. And what I really want to drive home here is not whether or not you can follow the arrows, okay? It's that we know the definition of a function and we're able to recognize from a graph whether or not a particular mapping is a function. For 5 through 7, look at the graph and determine if it is a function. So 5 is maybe a bit of a challenge. And what I would recommend doing is taking like a ruler or the edge of your pencil, because if you have to like trace all of this, it might get very hard for you to see whether or not they're stacked up. Like some of them look like they might be kind of close. So if you take a pencil or something and you just kind of slide it across, that's where that name vertical line test gets its name for, because that pencil gives you that nice vertical line. And right here, we are going to see a violation of that vertical line test. I see 2 points that are stacked on top of each other. Now, what makes that one particularly challenging is because there is no pattern to the points. And most of the time, I've mentioned this before, most of the time in math, there will be a pattern to the points. In fact, we study the patterns. That's what almost all of Algebra 2 is studying the different kinds of patterns that functions can make. But when it's scattered, it is definitely harder to see if there's a pattern there. For number 6, that one is a function, and it's actually a specific kind. When I generated that, I was doing it a specific way. And if you've studied some of this, you might recognize what that pattern is. But again, you're just kind of looking to see if any of those points are stacked on top of each other. It does not matter if they are level. Okay, this is not a one-to-one function, but it is a function. Now, this one is moving in the direction where we're heading. What if instead of having a bunch of dots, you had what's called a continuous function, or I guess continuous curve, because we're asked to determine if it's a function, but remember that curve is just made up of an infinite number of individual points. So you're still looking for the same thing. You're looking to see if that graph ever doubles back on itself as you trace it. So does it ever get to be vertical where 2 of those points would be stacked on top of each other? The answer to that is no, it doesn't. So it does pass the vertical line test. That one is a yes. Now, just in case you got that wrong and you're like, I thought they were stacked up. I thought it looked like it was vertical. Here's what you would be looking for that would be a no. You would be looking for something that did that. Okay, and that one would be a no, because you could clearly see that you had vertical points that were stacked up. Okay, so if it looks like, that looks really close, probably it is a function. It just looks like it's very, very, very steep, but it's not actually vertical. Okay, so that's just a little tip for if you're shown these. Now for 8 and 9, I'm asking you to find the pattern in the function, and there's a bunch of ways you can do that. So looking at number 8, let's take a peek at number 8. I'm going to go ahead and list these ordered pairs out. So -1 is mapping to -5. 0 is going to -4. 1 is going to -3, and 2 is going to -2. So you can take a look at that and look to see, how am I getting from the X to the Y? What am I doing to get from X to Y? This might be enough for some of you. You look at that and you're like, I see it. I see how we're getting there. If it is not, okay, it might be beneficial to look at the graph. Okay, and -1, 0, 1, 2. So we might take a peek at this. -1, -5, 0, -4, 1, -3, and 2, -2. And you can see that that is a line. The y-intercept is -4. And it looks like the slope would be up 1 over 1. So the slope is 1. So looking at mx plus b, it would be 1x minus 4, or just x minus 4. So let's double check. To get the y value, do I do x minus 4? -1 minus 4 is -5. 0 minus 4 is -4. 1 minus 4 is -3. 2 minus 4 is -2. So that is the pattern for number 8. All right, number 9. Okay, doing the same thing. So -1 looks like we're going to -2. 0 is mapping to 0. 1 is mapping to 2, and 2 is mapping to 4. Now, here's a tip for what I do when I'm asked to do this. Typically, positive numbers are easier to work with than negative numbers. They just are. Okay, they are just easier to see stuff with positive numbers. So as I look at this, what it looks like to me is that we're multiplying by 2. Okay. And then what I'll do is I'll test that and see if it works for the other one. So 2 times 2 is 4, 1 times 2 is 2, 0 times 2 is 0, -1 times 2 is -2. So I feel pretty good about that. Let's go ahead and just check out the graph just to check it out. So you got these ones, and then 1, 2, 3, 4, 1, 2. And let's see, so -1, -2, 0, 0, 1, 2, and 2, 4. So that looks like a y-intercept of 0. And if you were to look at this, we are going up 2 over 1. So my slope would be 2. My y-intercept would be 0. So this would be 2x plus 0, or just 2x, which is what we thought looking at the set of ordered pairs. So again, a lot of stuff coming together with these problems. So we've got the idea of the mapping, and then this pattern in the mapping, and the pattern in that mapping is related over to our graphs that we have studied before. And last question on this, state the domain and range for number 9. So that is practicing our vocabulary. The domain, so I'm going to use, well, typically I would do this, just a capital D for the domain. And my domain is the -1, 0, 1, 2. And for range, I will typically use a capital R. Open up my set brackets, and that's going to be -2, 0, 2, and 4. And this is the notation that you would use. You would use like a capital letter and then a colon, and then you would open up your set brackets, and then you would list the elements of the set. Now, I did not cover that in the lesson. So if you just like said domain and just listed the numbers, yeah, that's fine. Okay, we didn't go into notation, and typically you would not at this level, okay, go into the notation, but there it is. All right, so that's it. Please don't forget to like and subscribe for more math help. Drop a comment or question below. And again, I'm sorry about the arrows. If you do want to say something very negative about them, just try to be nice about it. Check out, I know they're bad. They'll be better in the next time I do it. Check out the other videos and playlists that we have on the channel. I'll go ahead and link some of our shorts or something below so you can check those out. And I will see you in the next video.